Alright, now we're going to cover competency 1 of the math GK exam, but only sub-skill number 1, and that is comparing real numbers and identifying their location on a number line. We're going to discuss what a real number is, how to identify their location on a number line. Pretty straightforward with the competency description here. So first we need to know what in the world is a real number. And then we're going to work on a problem where we're going to identify their location on a number line, and we're going to rank them from least to greatest. If you want to do greatest to least, you'll have them in the reverse order that we do. But it's a good practice to see if you come up with the same thing without remembering everything. Alright, so what is a real number? A real number is any number that you can think of is a real number. They can be whole numbers, rational and irrational numbers. They cannot be imaginary numbers, and infinity does not fall in the realm of real numbers. And if you think about it, I said any number you can think of is a real number. Well, it's hard to think of an infinite number of objects. You really cannot wrap your mind around it. It's hard enough to wrap your mind around 40 million of one object. Now, think of that on a piece of paper as a single point, and then filling that entire paper with more points, and you're still no closer to infinity. So that doesn't fall in the realm of real numbers at all. And imaginary numbers, if you've seen it before, the square root of -1, where you get I, so something like 3i does not qualify and does not work as a real number. Basically, they're real numbers because they are not imaginary numbers. Alright. That's the description of real numbers. Let's move on to identifying their location on a number line. So I'm going to give a few numbers here, and we're going to discuss strategies that really I find to be the best when doing these types of questions. Let's do 2 more. And good old 1. Everybody likes 1. So where our target's to go least to greatest. Well, let's see here. We have some that are pretty straightforward. 5, 1.25, and 1. I can do those really easily. I know 1's going to be around, first of these 3. Then 1.25, then 5. I still have these 4 to worry about. So what can we do? Well, what I like to do is go and get everything into its decimal number form. So, and as always on this test, we're going to use 3.14 as pi. And then we're going to have 1/3 is 0.3 repeating. Let's do 15 over 4. Well, 4 goes into 15 3 times with a remainder of 3. So 3 over 4, 0.75. And 16 over 3, well, 3 goes into 16 5 times with a remainder of 1. So 1 over 3 is 0.333 repeating. So now we kind of have all of them. So I'm going to write the other ones in that were kind of give-me's for this approach. And we're no longer going to be looking at these numbers. Alright, so now we're going to go from least to greatest. What I like to start with is the decimal is always my friend here. I always start with 0 to the left of the decimal, and if I can identify any of them, that's going to be where I start. I'm going to mark them right now. This is 5 to the left, 1 to the left, 3 to the left. This is an understood 0 here. So I'm going to go ahead and mark that one. I have 3 to the left and 5 to the left and, well, 1 to the left. So we know that 1 is the same as 1.0. Alright, so I have 1 here. So I'm going to go ahead and say, well, I marked nothing else. I'm going to go ahead and put my 0.33 repeating here. And I'm going to come back and cross it out because I've used it. Now I'm going to pick, I went from 0 to the left of the decimal. Now what I want is 1 to the left of the decimal. Well, I've got 1 here. That's a 3, that's a 3, and that's a 5. And that's a 1. So now I have 2 to choose from. So now I have to make the decision. Well, I think it's pretty obvious that 1 is less than 1.25. And then we're going to cross them out because we've used them. Now I'm going to go to 2. Well, there's no 2s to the left of the decimal, but there are some 3s. 3.14 and 3.75. Well, That's a pretty easy one to decide on. And this is very easy because we went to decimal form for every one of these numbers so far. And last but not least, we are going to look for anything 4 to the left. Nope. 5. We have 2. Well, 5.0 is definitely less than 5.333 repeating. So now we're pretty much there. Take a second to think about what's the one thing we really have to do before we can finalize our answer and start looking for our options on this test. Well, they didn't know we decided to work everything in the decimal number form, so we need to convert them back to their original numbers. And here's where you might regret scribbling through everything. So, well, luckily we wrote them in order. So we have 0.333, so we're going to have 1/3. I know we didn't change the 1. 1.25 was an original number we started with. Then we had the symbol for pi. Then we had 15/4. And then we had 5. And then we had 16/3. This is the answer you're going to look for on the test. If this is an option, this is it. Let me see if there's anything else to cover here. 1/3 1.25 pi. Yeah, this looks great to me. This is what I would be doing on the test. If you have any questions, let me know. Oh, I guess what we can do, since it did say identify their location on a number line, we'll go ahead and do that. We didn't include any negative numbers in this example, so even though the video sounded like it was winding down, let's add 1 or 2. So let's come back in here and break the rules a little bit and give a -2 and a negative pi. So now here is our amended final answer, and we're going to draw a number line. And here is 0. Let me get a straight edge because good enough. I think that's the most I've used my TI-84 this year. Alright, so we're starting at 0. Well, we need to identify where would 0 fall in this set of numbers. Well, we have negative pi, -2, +3. So 0 occurred somewhere in here. It's approximately 0. So now I know everything to the left is going to be to the left of the 0 on my number line, and everything to the right of that mark is going to be to the right. Just a quick, easy 2 seconds that we spent to have a little bit better peace of mind. Let's make everything negative red. And we'll say pi, negative pi is here. And then we're going to move on. Well, 1/3 would be about here. Let's call this 1. 1 1/4. Pi would be a little bit further out. 15/4, which is 3.75. So that's going to be a little bit closer. And of course this is not to scale, but I'm trying to give some gaps here, kind of get it in your mind. And we'll call 5 out to here, and 5 1/3, or 16/3. Well, that's how you put it on a number line. And there it is. Competency 1, subpoint number 1. Compare real numbers and identify their location on a number line.